Welcome to the educational research section of www.happynumbers.org. Today's lesson is going to deal with explanatory and response variables, and we're going to deal with the case of a categorical explanatory variable and a categorical response variable, or the case of CC. Many of the examples in this video are taken from the Carnegie Mellon website, where they present a great explanation of basic statistics and how to interpret data. And here is the URL for that, and I would recommend that you take a look at it. It's for free, and it's wonderful. Some prior knowledge that you will need to understand this video, or to get the most out of this video. You'll need to have looked at the video or have a good understanding of the concepts of box plots and a 5-number summary. You'd need to know the interquartile range, and you will need to have looked at the video that talks about role type variable classifications. And these 3 videos are all on the website that you're looking at right now, www.happynumbers.org. Okay, well, let's take a look at the categorical explanatory variable and categorical response variable. Recall that we classified each of 2 relevant variables according to their type, either categorical or quantitative, and their role, explanatory or response. So here, let's take a look at this little diagram. Here we have our explanatory variables, and they can be categorical or quantitative. And here we have our response variables, and they can be categorical or quantitative. And so we get a grid. This box is represented by a categorical explanatory variable and a categorical response variable. This box would be represented, and let's take, might that be? Let's take a categorical explanatory and categorical response variable. Might be if we were doing a study on gun control attitudes, and we were using political affiliation as the explanatory variable. In other words, we're assuming that what political party one has or what political affiliation one has might influence their attitudes on gun control. So we have Republican, Democratic, and Independent. Well, those are categorical. So this is the explanatory variable, and that's categorical. And the response variable would be attitude towards gun control, and the choices would be there for gun control, against it, or no option, or no opinion. And that's categorical also. So this would be a case of a categorical explanatory variable and a categorical response variable. We also have the case where we can have a categorical explanatory variable and a quantitative response variable. What a piece of research might look like if we had that. Well, suppose I think we did even look at research with type of hot dogs, the type of hot dogs, and the caloric content. So the explanatory variable was the type of hot dog, either beef, chicken, or meat. Meat being when meat was a combination of both. And those are categorical. And they are what the research is implying is that the type of hot dog will affect the caloric content. Well, this is the explanatory variable, and that's categorical. But the caloric content is a quantitative variable, and that's the response variable. So that's what a piece of research might look like if it had a categorical explanatory variable and a quantitative response variable. Then the next one, we could have a quantitative explanatory variable and a categorical response variable, and that would be represented by this box. And let's take a look at what that might look like. Well, let's say we are interested in IQ as the explanatory variable and political affiliation. So the assumption would be that a person's IQ would affect what particular political affiliation they would have. Well, IQ, which is the explanatory variable, is quantitative. IQ is quantitative. But the response variable, political affiliation, that's categorical. There's a category. So that piece of research might look like that. And finally, we have the quantitative explanatory variable and quantitative response variable. And that might look something like this. If we were looking at the relationship between IQ explaining or predicting SAT scores. Well, IQ is the explanatory variable, and the response variable is SAT scores, and both of those are quantitative. Good. Well, I just wanted to give a brief outline of what typical types of research might look like in each of these. Today we're going to look at the case of a categorical explanatory variable and a categorical response variable. Okay? And of course the reason that this is important is when you're reading research, you want to ask yourself what type or what role type variable classifications are the researchers assuming here, because that will affect their data analysis. Well, let's take a look at something. We have a research study where we're looking at 1,200 college students who were asked about their body weight. And we've looked at this data before, but now we're going to separate the data into males and females. Males and females. So the explanatory variable here will be gender, which is male or female, and that's categorical. So we have a categorical explanatory variable, and the response variable will be body image, either overweight, about right, or underweight. And that's categorical also. Well, this is what a piece of the data sheet might look like. We'd have a list of 1,200 students, and they'd be male or female, and their choice of their perception of their body weight, either overweight, about right, underweight, and so on. Now, this is just a sample of what the data sheet would be very long. So this kind of information is really not that useful. So we need a way to effectively be able to explore this particular data set. Well, we can use what is called a two-way table to explore this data set. Now let's take a look at this table. Here, the explanatory variable on the left here is female or male, gender, female or male, and that's categorical. And the response variable across the top here is perception of weight, and about right, overweight, underweight, and total. We have a column that totals up the explanatory variable and a column that totals the response variable. So let's take female here. There were 560 females that saw themselves about right. There were 163 females that saw themselves overweight. There were 37 females that saw themselves underweight. And there were a total of 760 females in the study. Males, there were 295 that saw themselves about right. There were 72 that saw themselves overweight. There were 73 that reported they were underweight, for a total of 440 males. And if we total up all the males and females, we get 1,200. This total here says that of all of the people in the study that saw themselves about right, 855, all the people in the study that saw themselves overweight were 235, and all the people in the study that saw themselves underweight, 110, and again the total is 1,200. Let's take a look here. The number of females in our sample who feel they are underweight is, well, we would just go to the female row and go over to underweight, and that would be 37. Let's see how we did. Yes, 37, good. The number of males who feel they are about right is, well, we go to the row for males, and we go about right, and we have 295. The total number of females in the sample is, I'll let you figure that out and then I'll click on it. Total number of females. Good, you would go to the female row and you would go all the way over to the total, and it should be 760. Yep. The total number of students who feel they are overweight is. I'll let you work on that for a minute. Well, you go to the column for overweight and go down to the total, and we have 235. Let's see how we did. Good. Pardon me. So, fairly easy to interpret that table. However, one of the problems with that is that there are more females in the study than males, and so just looking at the raw data doesn't quite help us that much. So it would be nice if we could change that data to percents. So let's see what we can do. Okay, here is our chart again. And this is the raw data. And again, I put the raw data here, but this will change it into a percent. So we need to convert this 560 into a percent. The way you do that is you take 560, the total number of females that saw themselves about right, and you divide that by the total number of females, 760, and multiply it by 100, and you get 73.7% of the females saw themselves about right. Now let's take a look at the overweight. We take the total number of females that saw themselves overweight, we divide that by the total number of females, 760, multiply it by 100, and we get the percent. So 21.5% of the females saw themselves overweight. Let's look at underweight. We take the total number of females that saw themselves underweight, which is 37. We divide by the total number of females, which is 760, and we get 4.9%. And of course, if we take the total number of females and we divide it by the total number of females and multiply by 100, we get 100% because that's the total. So again, to change any one of these cells into a percent, you take the total number in the cell and you multiply it by the total number of the attribute you're looking at and multiply by 100. So, in terms of females, 73.7% saw themselves about right, 21.5% saw themselves about overweight, and 4.9% saw themselves underweight. Let's take a look at the males. We take the total number of males who saw themselves about right, which is 295. We divide it by the total number of males, which is 440, and multiply by 100, and we get 67% of the males see themselves as about right. Let's take the males and who saw themselves as overweight. You take the total number of males who saw themselves overweight, which is 72, divided by the total number of males, 440, times 100 gives you 16.4% of males who saw themselves overweight. And males who saw themselves underweight, you take the total number of males who saw themselves underweight, which is 73, you divide it by the total number of males, 440, and you get 16.6% of males who saw themselves underweight. And of course, if you took the total number of males, which is 440, and divided by the total number of males, which is 440, you'd get 100%. So, now we've converted our data into percent. And this should give us a better insight into the data set, because it takes into account the difference between the larger number of females and over males, and changes all of their scores into percent. So we can see females saw themselves, the majority of females and males saw themselves as sort of about right. Interesting that females saw themselves overweight 21.5%, where males only saw themselves overweight 16.4%. And it may be that females, our culture forces them to be a little more conscious of their body image and things like that. I don't know, I'm just speculating, but thought that was interesting. And underweight, 4.9% or 5% of the females saw themselves as underweight, whereas almost 17% of the males saw themselves as underweight. Interesting. Okay, so this two-way table, or a table like this, is a very good way to take a look at data when you have a categorical explanatory variable and a categorical response variable. And the skill of taking the raw data, the raw number, and changing it into a percent is an important skill. You should know how to do that. Again, the process is you take the number in the cell and you multiply it, you divide it by the total number, in this case, in that row, and then you multiply times 100, and that will convert it to a percent. Okay, again, that's an important skill that you should know. You should know how to do that. Let's go on here. Okay, a study was done to answer the question, is the smoking of students related to their parents' smoking habits? And let's take a look at that. Data were collected on 5,375 students, and we have a two-way table. Here we have the explanatory variable on the top and the response variable on the side. The explanatory variable was parents, whether parents smoked or not. So here's parents. This column represents parents who did not smoke. This column represents parents who did smoke. This row, the response variable, represents students who did not smoke. This row represents students who did smoke. And these are the totals. So the total of everyone in the study is 5,375. Parents who did not smoke, the total was 1,356. Parents who smoked, 4,019. Students who didn't smoke, 4,371 total, and students who smoked, 1,004. Those are the totals. Well, again, this kind of data doesn't really help us. The raw data doesn't really help us. So if we changed it to percents, and through the magic of the computer, if I click here, it'll do that. And so here I have 86% of parents did not smoke and their students did not smoke. Here I have 79.7% parents who smoked and students did not smoke. Here I have 13.9% parents did not smoke and students smoked. And here I have 20.3% parents who smoked and students who smoked. Well, what conclusions can we draw from that? And that's a little tricky looking at that data, but suppose we represented it like this in a graph. Here we have parents who did not smoke, and this is students who did not smoke, and this is students who did smoke. Here we had parents who did smoke, and this is students who did not smoke, and students who smoked. So we can see, by looking at that whether the parent smokes or not has some effect, according to this data, seems to have some effect on whether students smoked or not. Again, another way of representing data when we have two categorical variables, a categorical explanatory variable and a categorical response variable. So, summarize. The relationship between two categorical variables is summarized using data display, a two-way table, which we had some examples of, and the raw data being converted into percents. And we also, the conditional percentages, and then we also represented the data by a graph. Well, okay, that is the example of some simple data analysis methods when you have a categorical explanatory variable and a categorical response variable. Thank you very much.